Okay, for the second part of the multiple regression assignment, I'm going to demonstrate how to use orthogonal coding to examine the best fit for a line based on the data. And so what we're going to do is examine a linear trend as compared to a curvilinear trend in the data. Now the reason we do this is because if we look at our data and we go to legacy dialogs under graphs and we create a scatter plot, and if we move performance into the x-axis, or the y-axis, I'm sorry, that's our dependent variable, and anxiety to the x-axis. Now we don't want to move any of these over. We just want the full anxiety variable with the three groups. And we create that scatter plot. Our data looks something like this. And if we fit a line to that data, we can see what the line looks like. It doesn't seem to fit the data very well. So let's create the scatter plot again. And we'll go through the same process. And this time, when we fit our line, let's we want to double click here, and we're going to use this line that has a curve in it. And we don't want the straight line, but we want the spline. And if we apply that, we can see that now we have a curved line that fits the data. And so what we need to determine is, using SPSS, is does the straight line or does the curved line fit the data better? Now, it seems to me, just by viewing this, that the curved line fits better, but we're going to find out. So we're going to go back to our data window, and in order to determine which line fits the data better, we need to set up our orthogonal codes. Now, your Week 8 assignment shows you how to structure the coding for a straight line or a positive trend and a curvilinear trend. So for the positive trend line, we're going to set it up as -1 for the low anxiety group individuals, and then the people that have moderate anxiety or medium anxiety will get 0, and the people with high anxiety will get 1s. Now, again, according to the information in your assignment, if we look at constructing the coding for a curvilinear trend, the low individuals, again, will get a -1. The moderate individuals will get a 2. And the high individuals will get a -1. Okay, so what you're going to want to do too is when you get finished coding and you've been able to run the analysis correctly, you're going to take a screenshot of this spreadsheet so I can see that you've coded correctly. So now we can go to Analyze, Regression, and Linear. Now in this case, what we're going to do is put task performance in the dependent box, and we'll put the orthogonal positive trend in the independent box and the orthogonal curvilinear trend in the independent box. So make sure you have 0, 1 and 0, 2 in your independent variable box. And then we can run the analysis. Now we don't want the statistics, because what the statistics will do is give us the means for how we coded the groups, and that's really what we don't want, and that can be somewhat confusing. But we can go ahead and run the analysis just as we did prior. And now we can see that our R square again is 0.54. So 54% of the variance in task performance is due to differences among high, moderate, and low anxiety groups. And this variability is explaining a significant portion of task performance. And we see that because this is highly significant. So this 54% that is being explained by group differences is significant. Then we see our coefficient table. And the way that we interpret this is that the constant is the grand mean of y, or the mean performance score for all students in the sample. So if we added all the scores up and divided by, let's see, how many were in there? There were 15. And we divided by 15, our grand mean would be 76.53. The orthogonal positive linear trend, the beta coefficient is 2.8. And what this means is that the predicted increase in y for a 1 unit increase in x, which is represented by the orthogonal positive linear trend, means that in this case, an increase of 2.8 points in performance is for 1 unit increase in the anxiety score. Okay, and for the orthogonal linear curvilinear trend, the quadratic trend, we see that our equation is, if we were to construct the regression equation, would be in this case we would be predicting 4.9 in performance for 1 unit increase in your anxiety score. So 4.9 units of performance, task performance increase for every 1 unit increase in the anxiety score. So we can see here that the positive linear trend is not significant. So it does not significantly fit the data well, whereas the curvilinear trend is significant. It does fit the data well, and it provides us a better representation or a better predictive quality. So if we go back up here, we can see that our straight line really kind of ignores these data points, where our curvilinear line takes the moderate anxiety data points into account. Please let me know if you have other questions. I'll be happy to help. Thank you.